Hi viewers, welcome to LMS Solution. Today we are going to see about MPPT Solar Charger Controller with two MPPT. One is ANN MPPT, another one is P&O MPPT. So here you can see that the Simulink model for a MPPT Solar Charger Controller with ANN MPPT, and here you can see that this is the MPPT block. When you go inside that MPPT block, it contains at the ANN MPPT. That then ANN model receiving two input irradiation temperature. Based upon irradiation temperature, this model will be generate the V reference voltage or peak power voltage. So the peak power voltage is going to be compared with the PV voltage, and then it's going to be processed via PA controller. That PA controller will be generate the duty cycle. That duty cycle can be allowed based upon two conditions. So one is battery SOC, another one is battery fully charged voltage. If battery SOC is less than 100%, and then the battery voltage will be less than that fully charged voltage, then this duty cycle will be allowed to that PWM generator for generating pulse for that converter. If suppose this any one condition is not true, then that means, for example, if SOC is greater than or equal to 100%, then the duty cycle will be not allowed to that PWM generator. That means because already the system is fully charged, so it's not allowing the duty cycle to that PWM generator for generating pulse. Or else if the fully charged, that means battery voltage is more than that fully charged voltage, and during the time also it not allow the duty cycle. Here we are using ANN MPPT for extract the maximum power from the PV panel. And also I am going to explain that system detail. So here you can see that we are using a PV array. Single PV array power will be 250 watts, and then voltage will be 39.9 and 8.1 amps at the maximum power point condition. And then here we are using 4 series panel in the each string. That means here we are using 2 parallel string. Totally the PV can generate maximum power around 2000 watts at a standard test condition. That means 1000 watts per meter square and 25 degree Celsius. Then the PV system will be connected to the batteries. Battery here we are taken as 40 volt battery and 200 capacity battery. And same time in the output end of that converter here we are used to Zeta converter. So Zeta converter can perform both up mode as well as boost mode operation according with the duty cycle, according with the main voltage of the input side and the output side. Here the same point we are connected another load here we are connecting around the 0.8 watts load here, and this model will receive the different inputs like irradiation temperature, battery measurement like SOC, battery voltage, and then here we are sending the PV voltage and current, and here you can see that we are measuring the PV voltage, current and the power. Here we are measuring the battery voltage, current and the SOC of the battery, and here we are measuring the load voltage, load current, load power. The PV going to be connected to the battery via that converter. Converter will be controlled by means of ANN MPPT control along with the battery charging logic. This is about the MPPT Solar Charger Controller with the ANN MPPT. The same model. So here we are using same model, everything same. Here we are using P&O MPPT. This is a logic for P&O MPPT. That means we are measuring voltage and current, and then you have to find out the del P and del V. So next you have to check the del V. Based upon del V, you have to allow the small change in duty cycle. You have to allow plus a small change in the duty cycle, or you have to allow the negative small change in duty cycle based upon del V and del V conditions. Here you can see here, if in this switch, if del V is greater than 0, we are allowing negative small change in duty cycle. If del V is less than 0, then we are allowing the positive small change in duty cycle. In this switch, del V is greater than 0, then we have to allow the positive small change in duty cycle. When del V is less than 0, you have to allow the negative small change in duty cycle. So after that, here we will get either a positive or negative small change in duty cycle. In this switch, you have to check the del P. When del P is greater than 0, you have to allow this one. When the del P is less than 0, you have to allow this one. And then here we are accumulating that to small change in duty cycle, and then finally we will get the duty cycle, and the duty cycle will be processed by this battery charger controller. Already we explained based upon SOC of the battery and battery voltage. You have to compare with the SOC with 100 and the battery voltage will be with the fully charged voltage level. Based upon that, it will be allow the duty cycle for control that the Zeta converter. And here I'm going to test the model. Here you can see that this here I'm going to run the model with the change in irradiation condition. So initially I'm going to fix the irradiation equal to 1000 watts per meter square, and then after 5 seconds we are going to change the irradiation to 500 watts per meter square, and then you have to check the result of PV measurement, battery measurement and load measurement, as well as the same condition will be applied for the P and MPPT. Both ANN MPPT and P and MPPT will be operated with the same condition, and then you have to compare the result of both ANN and MPPT and the PO MPPT. So now I'm going to simulate this one. Next I'm going to simulate this one. Now we can see now the system is running now. So this is a result of ANN and MPPT. For 1000 watts per meter square, the voltage will be maintained around 125 volt, and then current will be maintained at 15 amps, and then we are getting around 2000 watts. After 5 seconds, irradiation changed to 500 watts per meter square. Because of that, PV power is around 1000 watts. And also you can see that current of the PV is around 7.5 amps. And this is known as battery voltage is maintained at 48 volt. And then here you can see here the battery current is around 30 amps when that irradiation is around 1000 watts per meter square. That means PV power is around 2000. When the irradiation change from 1000 to 500, then the charging level of the battery going to be changed from minus 30 amps to minus 10 amps. Now you will see that here you will get around 1000 watts only. So 1000 watts means is already told here load will be maintained at 500 watts. The 500 watts will be taken from the PV. The remaining will be used for charge the battery. Here you can see that charging of battery would have the different slope according with the charging current and the condition of the PV. So next I'm going to open that detail of. Here I need to make the load will be 500, and then I'm going to simulate the model. This is a result of in the DPT. Here also load will be maintained at 500 watts. There is no deviation in that. But here you can see the response of PV voltage, current and power. It will take some time to reach a maximum power point, and also the PV voltage and current will be having that oscillations. During change in irradiation condition from 1000 watts per meter square to 500 watts per meter square, here you will see that PV will be having large dip. It will be goes to low power value during that irradiation from 1000 to 500. This comes around 200 watts. After that, it will take some time to reach the maximum power point level. And also you can see the variation of voltage and current of the PV. And also you can see that during changing of irradiation, the current also having goes to more than 0 amps and then comes to minus 10 amps. So it will also have some transient during that. So when we compare with the result of ANN and MPPT, so this is a result of ANN and MPPT. So this is a result of PO MPPT. So when comparing the result of both, you can see that the ANN and MPPT will provide the smooth response. The transient response very smooth. There is no oscillation or a transient behavior in that PV voltage, current and battery current. So when comparing the both result, ANN providing the better result than the PO MPPT for a battery charging control. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming video. Thank you. Thank you so much. Bye bye.